When we're asked to complete the square on an expression, we use this rule here. So we're looking for the coefficient of the term that is to the whose pronumeral is to the power of 1, and then we take that pronumeral, we divide it by 2, and then we square the result to complete the square. So here's an example from exercise 2.15, question 1. The pronumeral that I'm looking at here is the x, and so the coefficient is the 4 there in front, so p is equal to 4 in this case. So over here, p on 2 all squared will be 4 over 2 all squared. Tidy up inside the brackets, 4 divided by 2 gives me 2, and 2 squared gives me 4. So that's the number that I now need to add on to x squared plus 4x to make that a perfect square. The problem here though is that now the line above isn't equal because I've added 4, so to even things out outside the brackets I need to also subtract 4, seeing as positive 4 take away 4 is going to cancel one another out. So let's have a look at another example. So this time p is negative 6. Now that negative is going to cancel out because when I square a negative number it becomes a positive. So we get negative 6 over 2 all squared. Negative 6 divided by 2 gives me negative 3, and negative 3 squared is positive 9. So that's the number that I need to add to the end of this expression. So I get b squared minus 6b plus 9. Notice that last term will always be positive because when we square a negative number it comes out to be positive. Now don't forget I also need to subtract that 9 on the end so that the top line is still equal to that second line. And I've just realised I forgot to do something in part 1. To fully factorise it, I can now write b squared minus 6b plus 9 as b minus 3 all squared. So let's just go back up and fix that one up in question 1. So I get x plus 2 all squared, and then I have to take away the 4 still on the outside. So you'll see that's the answer in the back. And question 2, I forgot to subtract that 9. Okay, so now they're fixed up. Let's just have a quick look at question 1 and 2 together again. Okay, number 15. It's not as difficult as it looks. Just use that magic number. So our coefficient here, the p, is 2 root 7 in this case. So I simply substitute in 2 root 7 for p. So I get 2 root 7 on 2, and then we need to square it. Now on this line here I can cancel the 2 on the bottom with the 2 on the top. So I'm just left with root 7 squared, and I'm just going to show the extra line in here. Root 7 all squared. Now remember our rule that a square root is the opposite of squaring something. So this will cancel with this and I'll simply be left with 7. So that's my magic number this time. So to complete the square on x squared plus 2 root 7x, I add 7. And then again outside brackets I need to also subtract 7 to ensure that it's still equal to the lines above. Now I factorise x squared plus 2 root 7x plus 7, and remember that our factor at the end, our last term, is going to be the square root of that constant that's on the end. So the square root of 7 is root 7. We square that, and then don't forget to subtract that 7.